morning, children. How are you all? I hope you all are safe. Children, in the previous presentation, I have told you that today we'll be starting with the next chapter, and the next chapter is not a periodicity, the principles and process of extraction of elements, but the next chapter is your P block elements. The chapter Principles and Process of Extraction of Elements is reduced from the syllabus by CBSE. So, we are starting with the next chapter, that is the P block elements. Now, what are P block elements? I have told you P block element comprises of all those elements in which the outermost electron enters the P subshell. Now, this block which I have highlighted of the periodic table is called the P block. It has the boron family called the 13th group element, carbon family called the 14th group element. These two we don't have to study. We have to start with the nitrogen family, that is the 15th group element. Then we have to do the oxygen family, the 16th group, then the 17th group, the fluorine family, and then the 18th group, that is the inert gases. So today I am starting with the 15th group elements. Now see what all elements are present in the 15th group of the periodic table. They are nitrogen having atomic number 7, phosphorus having atomic number 15, arsenic having atomic number 33, antimony 51, bismuth 83. So, the elements present in the 15th group of the periodic table are nitrogen, phosphorus, arsenic, antimony and bismuth. Now, coming to the electronic configuration of these atoms. For nitrogen, the atomic number, as I told you, is 7. The electronic configuration will be 1s2, 2s2, 2p, 3 plus 2 5 plus 2 7. Now instead of writing 1s2, we can simply write the inert gas which is coming before that. Before nitrogen, the inert gas that is coming is helium having atomic number 2. So this can be written as He inside a square bracket. We'll simply say that the electronic configuration of nitrogen is 2s2, 2p3. Similarly, phosphorus will be written as 1s2, 2s2, 2p6, 3s2, 3p3. Now, this portion can be written as neon. It is having 10 electrons. 6 plus 2 plus 2 is 10. So, it can be written as neon. So, we will simply write the electronic configuration of phosphorus as 3s2, 3p3. And arsenic will be 4s2, 4p3, 5s2, 5p3 and then 6s2, 6p3 for bismuth. So, we can simply say the general electronic configuration of this group of periodic table is Ns2, Np3. That means all these elements are having half filled p subshell. So, now this value of N will indicate the period of the periodic table to which it belongs. For example, nitrogen belongs to second period, phosphorus belongs to third period of the periodic table, arsenic belongs to fourth period of the periodic table, antimony belongs to fifth period of the periodic table and bismuth belongs to the sixth period. And before this 4F14 and 5D10, what are they? They are actually telling you about the configuration of the D and F subshell of the same period. So, you have to remember these electronic configurations. Now, coming to the third important point, that is the occurrence. How do these elements occur in nature? See children, except for phosphorus, these elements do not occur abundantly in nature. But if we talk about nitrogen, it comprises around 78% of the Earth's atmosphere. Phosphorus is present on the earth crust, but nitrogen is abundantly present in the earth's atmosphere, but it is not very abundant in the earth crust. In the earth crust, it simply occurs in the form of the ores, or you can say nitrates, like sodium nitrate or potassium nitrate. Other nitrates are also there. Now, nitrogen, it is an important constituent of proteins, amino acids, nucleic acids, and all these things are present in plants as well as animals. Children, phosphorus is the 11th most abundant element on the earth, and it occurs in the form of the ores of apatites like chloropapatite, fluorapapatite, etc. Now, arsenic, antimony and bismuth, they are not very abundant. They occur in traces in other ores. Coming to the oxidation state. All these elements have 5 electrons in the outermost shell, so they can exhibit either +3, +2, +1, -3, -2, -1, +1 to +5 oxidation state. But due to very small size of nitrogen, it favors to show only -3 oxidation state. But the stability of -3 oxidation state, it decreases as we move from top to bottom in the group. Why is it so? Because the size of atom increases and the metallic character increases. So, the stability of positive oxidation state increases down the group. In positive also, +3 is more stable, whereas +5 is not much stable. Why? It is because of the inert pair effect. Now, what is inert pair effect? The inner orbitals. These inner orbitals, like in case of bismuth, in between 6s and 6p, +3 is shown by due to the electrons present in this p subshell. But this 6s, it is embedded very deep inside, so these two electrons do not want to participate in the bonding. So, this reluctance shown by the inner electrons from taking part in bonding, it is called inert pair effect. So, I hope you have understood about the this oxidation state. These were your physical properties. Now, coming to the chemical properties and the trends in chemical properties. Now, before studying the chemical properties by numbers, we will study about the anomalous behavior of nitrogen first. Now, what is the meaning of anomalous behavior? Actually, the first element or the second period element of all the group, not only the nitrogen family, any family, it shows behavior which is different from rest of the members of the group. Like nitrogen also shows some behavior which is different from the other members of the group, and the reason behind the difference is very small size of the first element, high electronegativity of this element, high ionization enthalpy, and the most important one is the non-availability of the vacant d orbital. Now, nitrogen is having the smallest size in the group. Its electronegativity is the highest. Its high ionization enthalpy, and it do not have a vacant d orbital. What is the meaning of vacant d orbital? See, nitrogen, the atomic number is 7. Configuration will be 1s2, 2s2, 2p3. Now here you all can see the outermost shell available with nitrogen is second. That means the value of n is 2. When the value of n is 2, the value of azimuthal quantum number, this is the principal quantum number, and the azimuthal quantum number will be only 0 and 1. 0 means s orbital is permitted and 1 means p orbital is permitted. If there would have been 2 also, then d orbital would also have been there, but d orbital is not there with nitrogen. And because of this, what happens? Molecular nitrogen becomes very stable and very low reactive. Many a times a question comes in the board exam, why is dinitrogen inert? You all know this nitrogen gas, it is filled inside the packets of the chips or wafers. Why is it so? Because it will not react. Why it will not react? It is because of N triple bond N. Two nitrogen atoms are bonded through a triple bond. Because of the presence of this triple bond, why triple bond is possible here? It is possible because of very small size. And because of small size, it can form a triple bond and requires a lot of energy in order to break this triple bond. So, it becomes very stable and non-reactive. The second important point, it can form P pi multiple bond. P pi multiple bond is two p orbitals can overlap among each other and form a multiple bond. Like for example, in dinitrogen molecule, there was a multiple bond between two nitrogen atom. It is possible because of the small size. The third important point is catenation tendency is weaker in nitrogen. Catenation tendency means if we compare a single bond between nitrogen and nitrogen and a single bond between phosphorus and phosphorus, this bond will be stronger. But here this bond is very weak. Third is it cannot form p pi d pi multiple bond. Why? Because the d orbital is not available. That means it cannot extend its covalency beyond 3. It cannot form bonds more than 3. Whereas the other elements, phosphorus can form 4 bonds. The other elements can form 5 bonds also, but nitrogen cannot. This is called your anomalous behavior of nitrogen. Now, coming to the chemical properties, first is reactivity towards hydrogen. What happens when these elements react with hydrogen? They form hydrides like NH3, PH3, ASH3, SBH3, BiH3. These are hydrides of group 15th elements. Now, in these hydrides, the shape of the hydride is, this is nitrogen, this is the lone pair of electron, and these are the 3 hydrogen atoms which are actually arranged in the form of a pyramid. These are pyramidal hydrogen atoms. So, the shape you can simply say is pyramidal. Now, the important trends that we have to see. Now, the first thing you have to remember is that the hydrides of group 15th elements are basic in nature. How they are basic in nature? As I told you, there is a lone pair of electron with all these atoms, nitrogen, phosphorus, arsenic, antimony and bismuth. So, they have a lone pair of electron available for donation. So, they are acting as a Lewis base. Now, how we have to study how the basic strength varies from top to bottom. Now, see, from top to bottom, you all can see the size of atom increases. You all know that the size of atom increases. So, the basic character of the hydrides, it decreases. Why? Because in case of nitrogen, the size of atom is very small. There is a repulsion. So, nitrogen will easily give its lone pair of electron. Whereas bismuth, the size is very large, less repulsion is there. So, it will not easily give its, you can say, the lone pair of electrons. So, we can simply say, as we go down the group, the basic character of these hydrides decreases. The tendency to donate the electron pair, the lone pair of electron of these species decreases. You can say that NH3, ammonia, is distinctly basic. PH3 is weakly basic, and these three are very weakly basic. Other important thing is thermal reactivity, or you can say the thermal stability. If thermal stability we are talking about actually the bond length between nitrogen and hydrogen, or you can say bismuth and hydrogen. You all can see nitrogen is small, so the bond length will be less. Bismuth is big, bond length will be more. So which one of the two bond is stronger? Smaller bond or longer bond? Smaller is stronger. So you can simply say that the thermal stability of group 15th element decreases. This bond can easily break. Decreases as we move down the group. Next important thing is reducing property. They all are having hydrogen. If they give out hydrogen to some element, then reduction of that element takes place. Or you can say if hydrogen is given, the reduction of that compound takes place. Here the bond is strong, it will not easily give hydrogen. Here the bond is weak, it can easily give hydrogen. So it can give easily hydrogen, that means it is having more reducing character. Down the group, the reducing character increases. So three trends we have learned. First is the basic strength. Basic strength, how it varies down the group from top to bottom. Basic strength, I am writing BS for basic strength, it decreases. Second thing we have learned is thermal stability. From top to bottom, the thermal stability also decreases because the bond length increases. And the third important thing is the reducing character. From top to bottom, the reducing character increases. Clear? Okay. Now, second is the reactivity towards oxygen. Now what happens when these elements combine with oxygen? They form various types of oxides in which the oxidation state of the the element varies. Like nitrogen forms N2O, NO, N2O3, N2O4 and N2O5. Different oxides are formed by nitrogen. Phosphorus, as the size is bigger, forms oxides starting from the oxidation state +3, that is P4O6, P4O8, P4O5. Similarly, arsenic also forms two oxides, antimony also forms oxide and bismuth also forms two oxide. But the maximum, as you all can see, are formed by nitrogen. Now coming to the third important trend is the reactivity towards halogens. Now see, whenever any of these metals react with halogen, they form compounds having general formula MX3 and MX5. But nitrogen cannot form this MX5 because you all know it cannot form 5 bonds. It can form only 3 bonds. Phosphorus can form this as well as this. Like for example, phosphorus can form PCl3 as well as PCl5. This is phosphorus and this is the halogen. So it can form MX3 and MX5 type of compound. Now nitrogen, as I told you, can form NCl3 but cannot form NCl5 because it cannot make 5 bonds due to the inavailability of vacant d orbital. Now you have to remember the shapes as well. See, the shape of MX3 type of compound is pyramidal, whereas that of MX5 type of compound is trigonal planar. This is pyramidal, this is trigonal, bipyramidal. A triangle is there, one pyramid above the plane and the other pyramid below the plane. Now coming to the fourth important chemical property, that is reactivity towards metal. You have to remember all the elements of group 15 combine with metal to form their binary compounds in which the element shows -3 oxidation state. Like for example, with magnesium it combines and form Mg2N3. With calcium it forms Ca3P2. With magnesium it forms Mg3Bi2, etc. So children, today we'll wind up with this, and in the next presentation we'll then start with we have to study the preparation, properties and uses of dinitrogen in detail, and some of the nitrogen compounds also we have to study. 2 nitrogen compounds we have to study, and we'll start with that in the next presentation. Thank you and Sai Ram.